Okay, so when we're asked to calculate mean, variance, and standard deviation, we have to use the formulas that we're given. So the formula for mean is going to be the sum of x, meaning we add all our individual x values together, divided by n, which is the total number of values that we have. The variance is going to be the sum of x squared, meaning we square each individual x value first, then we add them all together, divided by n, which is our total number, and then you're going to subtract the mean squared. So you always have to calculate mean first, because you're going to subtract that squared for the variance, and then the standard deviation is the square root of the variance. So sometimes what you can do is, if you're asked to calculate standard deviation and not variance, you can combine those two formulas by saying the standard deviation is the square root of your variance formula. So just by adding that square root in there, you will then get the standard deviation. So if we look at an example, for the following data set, I need to find the mean, the variance, and the standard deviation. So I have a specific set of numbers that I need to find the mean, the variance, and the standard deviation for. So starting with the mean. So the mean, we can use that symbol x with the line on top, which represents mean. And we can say that that is going to equal the sum of x over n. Now the sum of x is going to be each individual x value added together. So we're going to say that equals 5 plus 6 plus 6 plus 8, etc. Each adding your numbers all up. And then you're going to divide that all by the total of numbers that we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 numbers that we're going to divide by. And if you type that into your calculator, you end up with a final answer of 9.7. So then the variance, we're going to use our formula sum of x squared over n minus the mean squared. So we're going to take each individual x value that we have, and you're first going to square it, and then you're going to add it together. So you're going to say 5 squared plus 6 squared plus 6 squared, etc. So you're going to square each and every one of those values. That you're going to have. Type that in your calculator, and that's going to be divided by your total number of values, which was 10. And then from this whole thing, you are going to subtract the mean squared, which is our 9.7 squared. And when you type that all in your calculator, you get your variance answer. And then the standard deviation is going to be the square root of that variance to get a final answer. So that's how we would do something with just a single set of numbers. But now sometimes, instead of having all individual numbers, we'll be dealing with hundreds or 150 or things like that of our sample. So when we're dealing with those large amounts of numbers, things are summarized usually into a frequency table. And when we have a frequency table, we use a slightly different formula. So for grouped information that we have, we're going to say our mean would be the sum of x times f. So the sum of each individual x value times the frequency of that value over n, and n is then going to be the total frequency in the table. When you add them all up, because that's the total amount that we sampled, Variance is then going to be sum of x squared times the frequency. So first you square each x value, then you times it by frequency, and then divide it by the total number that you sampled, minus that mean squared. And then standard deviation is still going to be the square root of the variance. So if we look at an example, I have got a whole bunch of x values, and I've summarized the frequency of each of those x values. So what you're going to do to find the mean is you are going to say the sum of x times f over n. So now, the x value there, the first one is 1, times frequency, so that's times 4, plus, because we're summing the next one, which is going to be 2 times its frequency of 5, plus 3 times 8. And you're going to do that for every single one of them. That's 4 times 10 plus 5 times 17 plus 6 times 5 plus 7 times 1. And that whole thing is going to be put over the total number of samples. So we're going to say, if we say 4 plus 5 plus 8 plus 10 plus 17 plus 5 plus 1, that will all add up to 50 on our calculator, and that is then going to be the n. So if you type that in, you get a mean of 4. And then for variance, we're going to do the same thing, but now it's the sum of x squared minus the mean squared. So we're first going to square each x value before we times it by the frequency. So we're going to say 1 squared times 4 plus 2 squared times 5 plus 3 squared times 8. And you're going to carry on with all of those, divided by n, which is still 50, minus the mean, which we just calculated, was 4 squared, to get a final answer of 2.2, if you type it in your calculator. And then the standard deviation is going to be the square root of that, which we're going to say is 2.2, to give us 1.48 as our final answer. Okay, and then I could have a frequency table that has been grouped together. So over there, it was each individual x value. But now here, my x values are grouped with their frequencies. So when they're grouped like this, the first thing I have to do is I have to find what I call the midpoint. So now my midpoint is going to be the middle point in each of those, and that's what I can use as an x value for my formula. So to find the midpoint, I'm going to say my beginning one plus my end one divided by 2. And I can see that each of these is continuous because there is greater than or less than signs. So I can use those as they are. So I can say 0 plus 15 divided by 2 to give me a middle value. Then I can say for the next one, 15 plus 30 divided by 2 to get the next middle value. 30 plus 50 divided by 2 to give me the next one, then 50 plus 70 divided by 2, and that will give us our midpoint, and then our last one, 70 plus 100 divided by 2 to give us our last one. So each of these now becomes an x value in the formula. So those are my each individual x values. So now when I want to calculate my mean, I use my same formula, mean equals sum of x times f, because we still got a frequency table, divided by n. So then I'm going to take each individual midpoint that I just worked out times by its frequency, plus the next one times by its frequency, plus and 60 times by its frequency, times by my last one. Okay, and that is all divided by the n, which if I add up all of those frequencies together gives me my total number, and if you add those all up, you get 400, and when you type that in, you get a final answer for mean. And then our variance, we're going to do exactly the same thing, except you're going to square each of those values before you times it by the frequency to add them all together over n, and then minus that mean squared. So then, the next example, now I have another table, but the only difference here is these are not continuous. So you know that when you have a non-continuous table like this and you're going to draw a cumulative frequency or a histogram, you first have to make them continuous by saying minus 0.5 on that side and plus 0.5 on that side. So we need to do exactly the same thing before we find our midpoint once we're doing our graph work. So my midpoint, we can take 0.5 away from there, which would end up with 30.5, plus adding 0.5 to that side to make it 35.5 divided by 2 to give me my final answer of 33. So then I can do that for the next one as well. And I can say 0.5 from the beginning makes it 35.5, adding 0.5 to the end makes that 40.5 over 2. And then 40.5 plus 45.5 divided by 2. $45.5 plus 50.5 divided by 2. Okay, and you're going to keep going for each of those. And then we do exactly the same thing with our mean being the sum of x times f. So now you just take the midpoint of each of them. Okay, over n, and then the variance is going to be the sum of x squared f over n minus that mean squared. So now each of those midpoints gets squared before timesing it by its frequency and adding it to the next one. And the n is still the total in the table, and the mean we're going to work out before that. Okay, so you always do the same thing for mean variance when you have individual values, or if you have grouped frequency information, just remember the difference in the formulas. But if I've been given the information about two different sets, and I'm asked to calculate a mean, like this one. So here, I have been given the information that I have 12 junior members and 20 senior members. For the junior members, we've got a mean of 15.5 and a standard deviation of 1.2, and the ages of the senior members summarized as sum of y and sum of y squared, where y is the age of the senior members. Now I need to find the mean age of all 32 members. So now I'm combining these senior members and these junior members, but you can't simply take the two means of each and add them together. That doesn't work. What we need is we have to take our sum of x information for each of them as the original that we added up for all our individual values, and then use that to find the new mean for all the members. So here, for the junior members, I'm only told the mean and I'm told the number of members. So I've got 12. So I know that my mean formula was the sum of x over n. And I've been told the mean is 15.5, so that can go in there. And I know that that's 12 members. So from that, I can work out sum of x because I have got everything except that one thing in the formula. So I can say that the sum of x is going to equal that mean value. Taking that to the top means it's times n. So the mean value was 15.5 times n, which is 12. So that gives me a sum of x value that I can work out to be 186. Okay, so now this is the sum of x for the junior members. Okay, because this was just junior. Now, I've already been told that the senior member's age is summarized by the sum of y. So if I have a sum of x and I have a sum of y, I can take those original values and add them together to find my new mean. So the new mean is going to equal my sum of x values for the junior members plus the sum of y values over n, which is going to be my new n. So that sum of x I just worked out as 186, plus I'm told the sum of y as 910, all over all 32 members, to give me my final answer of 34.25. And then the second part to this question would be find the standard deviation of all 32 members. So in order for us to find the standard deviation, just like we did with the mean, you have to work backwards to your sum of x squared values, and here we're given a sum of y squared values, so that we can add them together and work to find our variance. So here for the junior members, we're told the standard deviation is 1.2. So I know that my formula for variance is going to be the sum of x squared over n minus the mean squared. And the standard deviation is the square root of this. So I'm told that the standard deviation is 1.2. So that means that 1.2 squared is going to be the variance. Because if the square root is the standard deviation, the square is going to give us the opposite of the square root. And that is going to be the sum of x squared over n, which I know I have 12 junior members, okay, because this is for the juniors, minus the mean squared was 15.5, which we were told. So now I have an equation where I can solve for the sum of x squared. So if I rearrange by taking that to that side and making it positive and then multiplying that up, I end up with the sum of x squared being 290028 on my calculator. So now I have the sum of x squared. I was told the sum of y squared, and I just worked out a new mean for both of them on that page. So that means that I can then find the new standard deviation. So I can say that my variance is going to be the sum of x squared plus the sum of y squared over my new n minus my new mean squared. So if I fill those in with my values, I've got 2900.28 plus my y squared, they told me on the previous page, was 42850 all over my new value of n, which is going to be my 32, minus the mean that I just calculated on the previous page, which was 34.25 squared. And if I type that in a calculator, I will get an answer. And to get the standard deviation, I'm going to square root that to get a final answer. Okay, so you just got to remember that we've always got to work back to the original sum of values for each different data set before I can add them all together to calculate a new one, whenever I'm combining two different sets of information for two different groups.